Good morning, everyone. This is Anna Siefken, and we are about to start our third in a series with the Wilton E. Institute for Energy Innovation called Energy, Resilience, and COVID-19. And we are looking at critical issues with the energy and infrastructure, not only in Pittsburgh, but across the country. And so we have quite a few guests with us today that I'm going to introduce in a minute. But first, I just wanted to say welcome to all of you. Obviously, there are lots of impacts that are happening with the coronavirus, and we are well aware that many folks on the front lines are experiencing significant hardships. So I always like to start this by saying that we realize that infrastructure is a critically important thing, but a special thanks to all of our line workers, our frontline workers, our healthcare workers who are out there doing some really critically important work right now. So I want to remind everyone that we are recording this session. It will be available most likely later today. So if you have someone who is interested in seeing this, they can also view it at a future time. Additionally, I will be taking questions towards the end. And so please do use the question area in the chat box. So the Scott Institute is sort of the hub of energy-related activity at Carnegie Mellon University. We have about 150 faculty members working on energy-related topics, and so the idea of infrastructure and planning is critically important to the work that our faculty do. Our overarching goal is to bring together with this webinar, much like we do when we're meeting in person, thought leadership, faculty experts to speak to critically important topics. So today's webinar is actually called Discussing Technologies that Enable Resilient Electrical Infrastructure. I first want to say thank you to RE2, Robotics, a CMU startup that was instrumental in sort of getting this series kicked off. And so Travis is one of our guest speakers today. Additionally, I wanted to let you know about two upcoming sessions. And I'm going to insert a third one in the middle for those of you that are startups and innovators. So our next webinar is about infrastructure planning, and it's looking at resistance versus resilience framework. So how we can be thinking differently about the planning that we do. And then our webinar number 5, which is on June 18, is about utility planning. So we'll have leadership from different utilities in the region talking about some of the work that they've been doing. Inserted in the middle off of the webinar schedule, we are doing a special session for startups, and we're going to be talking with a local law firm, Babst Caland, actually with a national presence looking at innovation and IP. So very interesting sessions coming up. You can check our website for more information. And finally, I want to introduce our esteemed guests today. And I'm going to go through them. This is the last of our slides this morning. I'm going to move everyone so that you can see their faces. But I want to first give these introductions. So Dan Carnovale is the creator and manager of Eaton's Power Systems Experience Center in Pittsburgh, where each year more than 7,000 visitors, including a lot of students, I might add, from all over the world come to learn about power systems, energy management, and power quality. So Eaton is a power management company made up of over 97,000 employees doing business in more than 175 countries. So their energy efficient products and services help customers effectively manage electrical, hydraulic, and mechanical power more reliably, efficiently, safely, and sustainably. Thank you, Dan. Our second guest today is Matineh Eybpoosh, who's the CEO and co-founder of WattLearn, which is an AI software company for optimal dispatch of grid batteries. She led the company towards a successful acquisition in 2018 by an energy private equity firm, where Matineh, her team, and they're now leading the deployment of WattLearn's software to a fleet of utility scale batteries. So they're a startup out of CMU, as I mentioned, and they offer this software platform for autonomous and optimal operation of batteries, both behind and in front of the meter. So Julian Lamy is with us as well today from Tesla. So he completed his PhD from Carnegie Mellon in 2016 in EPP, where he focused on optimal siting decisions for renewable energy and energy storage projects. So shortly after, he co-founded WattLearn, then moved to Tesla, where he now leads optimization, algorithm development, and market participation for virtual power plants. So Tesla is an electric vehicle and clean energy company that specializes in energy vehicle manufacturing, battery storage from home to grid scale, and through its acquisition of SolarCity, solar panel and solar roof tile manufacturing. And then finally, we have Travis Schneider, who is the business development manager. He's responsible for the commercial market development at RE² Robotics. So since joining, he's helped to expand their commercial partnerships in aerospace, medical, and energy markets. And he has a decade of professional experience creating business-to-business partnerships and opportunities, applying automation or robotics within a variety of high-tech markets. So as I mentioned, RE² Robotics is a dynamic, growing tech company with a critical mission to develop innovative technologies that positively impact the world. So what could be better than that? So I've gotten through all of those extensive bios, and I want to say thanks to those guests of ours. I am going to stop sharing my screen so that we go back into this mode. Wonderful. So with that, I want to jump right in to some questions. So the first question I have as we get started this morning is, from each of your perspectives, what kind of impacts has COVID-19 had on the electricity grid? And how can technology improve energy resilience and continued stability of the grid? Who should be responsible for those new technologies? And WattLearn, why don't we start with you?
Sure. Can you hear me?
Yes.
Okay. Good morning, everyone. It's very good to be here. Thanks for the invitation. I would like to address this question from two different angles. The first is more like a local impact that we have been seeing in the electrical grid, which is something that I have been dealing with on day-to-day basis because of WattLearn's business. So one of the main impacts has been the change in the load profile, and in some cases, the change in generation profile of the electricity grid due to this pandemic. So far, the changes have been in the form of reduction in the demand and thus the prices of the electricity wholesale market. The reduction in some areas have become, the reduction in the price and in the load have been, in some areas, been very substantial, like down to 25% in some areas. And this has led to negative prices. More and more we are seeing negative prices on a daily basis. And negative prices have their own challenges. What that means is that in order for a supplier to provide, to keep the lights on, they not only are getting paid to do so, but they actually have to pay to do so. So we can imagine what kind of challenges that can bring into a market that we are trying to keep competitive. At least that's a model that in the electricity grid in US we are trying to achieve. So by itself, reduction in demand is not a challenge per se directly for resilience, because our infrastructure can handle like lower demand. That's not a problem, but there are indirect aspects of it. As I said, like these negative prices and the uncertainties about what is going to happen next, or challenges. The negative prices, for example, cannot be sustainable. So are these, if these patterns continue, are they going to lead some power plants to retire sooner than expected? There's also like this planning about the electricity grid. Like it's so complicated to plan electricity grid. We look years in advance and years past. We look at a lot of data, analyze a lot of data, model our electricity grid. And for example, a lot of maintenances of power plants are scheduled based on the consumption pattern. So for example, in shoulder months or when the consumption is less, but now everything has changed. Now all of a sudden we have people working from home. We have this industrial load that has kind of eliminated. We have this shift in the location of the load. So now the question is, okay, so the load is lower now, but when is it going to peak? And is it going to peak when we expect it least, when we are less prepared, and when we have less supply? And when is going to be the next similar situation? Is it? Like, probably not, but is it the only pandemic that we had and we're good to go, or more is going to come? So, and the problem with this type of issue that we have been seeing, like COVID-19, is that we are not really like prepared in terms of grid planning for it, because this is a little bit different than other contingency plannings that we have for the electricity grid, like natural disasters or even cybersecurity, because this has the whole new level to it in terms of being a global for example, another aspects of the impact that we are seeing is the global aspect of it, and that is because we know that the supply chain of a lot of energy projects is a global market, and that has impacted progress of energy projects, especially renewable energy. For example, energy storage is one of the cases. A lot of clean energy technologies are manufactured in China, which is one of the most affected areas. The capital investment on projects have been stopped or slowed down, and that affects the growth of renewables and energy storage, which we know is in fact one of our ways to get to resilient grid. So all of these are challenges that are very unique to this COVID-19 and similar situations that I don't think we are prepared for, and at least not as well as we are familiar and prepared for other sort of disasters. But how the technology can help, I would say, as I mentioned, there are a lot of data information that needs to be processed and modeled and planned for future. And I think we need to more and more adopt data-driven and advanced analytics solutions to be prepared, not for only the uncertainties that are coming, but also when we are right at the middle of it. Like yes. Right now, like we can use a lot of those kind of innovative data-driven approaches to address a lot of these problems, because at the end of the day, electricity grid is such a socio-ecological system. It is not just one aspect that we have to handle and then we are good. There are so many information and data that we need to process and evaluate at the same time, that I think artificial intelligence and advanced analytics would be a very good and things like IoT, those kind of technologies, I think can be very helpful to get us out of this.
So I completely agree, the idea of using data. So Julian, how is Tesla thinking about this same topic?
Yeah, hi everyone. So the way I like to think about resilience and energy is that there are kind of three components that we really need: is flexibility, automation, and something that's scalable. And I think it's even more important now whether there's a natural disaster or a pandemic, having these three characteristics make it such that your grid can adapt in different situations. And so I really think what the most compelling story is in the energy industry today is really a combination of two things, which are radical innovations in first batteries. We're finally at a point where we have high performing batteries that are cost effective, enough to be investable, enough to be bankable, where pretty much every energy company that's developing renewable energy projects is developing renewable energy projects with batteries. So it's really taking the industry by storm. But the second thing that's really important here is not just having that flexible resource like a battery, but having something that can automate the operation. And so having AI algorithms combined with cloud architecture to be able to fully automate the operation of these assets, in a way where you really can replace an entire trading desk or bidding into markets and monetizing that asset. And to some extent, even plant operators. So it's more of a job shift as opposed to job replacement. But the point here is that, more towards engineering and monitoring of those assets. But the point here is that it becomes more flexible. You don't have to rely on trucks rolling necessarily, or people showing up in an office to make sure that those assets can operate. And so, yeah.
Thank you. So let's talk about at RE Squared. How are you all dealing with the changes that have come up, and are there particular strategies that you've been using to address them?
Yeah, thanks, Anna. So I think, COVID-19 has highlighted that despite it being the year 2020, it seems that we're still heavily dependent upon, direct manual labor to conduct many of these tasks, to either, repair or maintain electrical equipment. Most notably, I'll point to the fact that there's been significant increases in infection, particularly within Northeastern utilities, forcing many to implement labor force-based, emergency planning to try to stay one step ahead in order to ensure that they've got the appropriate staffing levels. So that's where I believe that, human-like robotics can be used to augment, human labor by projecting their capability. Thus, it'll help maintain a higher degree of safety, not only from COVID-19, but also from things like arc flash or arc blast hazards. So effectively, I'd say that robotics can add one additional layer of resilience by lowering our dependence on that direct manual labor and helping to maybe automate some of those tasks, as Julian was alluding to, but in other cases, just to provide an additional layer of support for those laborers on the front lines.
Thank you. Very important, those frontline workers. So let's talk a little bit about distributed energy resources, generation, and microgrids. So what role can and should DER play as we improve resiliency and reliability kind of in the future and with recovery efforts? And how have renewable development projects been affected? So I'm actually going to shift over, and Dan, have you speak to some of those things. Right, as you have a guest coming by.
Yeah, thank you. I appreciate it. So what we've done is here in Pittsburgh, we built a place we call the Power Systems Experience Center. It's a large demonstration system that we built here, and each year we bring in, as you mentioned earlier, students through very educated and people that are well into the industry and engineering, and all the way up through CEOs. We always make the joke that we talk from fifth graders to CEOs, and the fifth graders usually ask the more difficult questions, but as you can imagine. At this facility, we have a couple microgrids, and so what we do is we'll take one of, like, for example, Julian's Tesla Powerwalls. We'll use those, our own X storage unit, Green Machine Battery, which is an interesting company, Samsung and LG Chem batteries. So as Julian mentioned, technology in batteries is really advanced. We've also installed a lot of solar, windmill, 3 natural gas generators, and things that were, showing grid connection and islanding, just really around optimizing, whether it's resiliency or whether it's around energy efficiency. So in fact, a lot of people call this place Disneyland for engineers or electrical people. So we actually have a lot of fun here. You can see in the background the kind of stuff that's going on here. So whether it's for the purpose of resiliency or cost savings, though, microgrids, as we talked about, are really an important consideration for power systems today. And basically, as we look forward, the main thing is with the key element of resiliency for crisis events will really be that continued energy transition to greater use of renewables, like we're showing here with solar systems and the wind and other systems, and the energy storage technologies are really helping to enable all that, really within the power infrastructure. So local generation and self-sufficiency of power, like we enable with microgrids, will really be vital for the business continuity and communities to ensure the continuity no matter what's happening. As Julian mentioned, or talked about with the batteries, being able to distribute that energy with storage is really a huge factor in getting us through something like we're experiencing now with COVID-19.
So I want to remind everyone that you all can ask questions in the Q&A. I want to make sure we get a few questions moving. You mentioned Tesla a few times in your response. So Julian, how are you all thinking about DER and microgrids in this recovery process?
Yeah, no, I think really the biggest story in the next decade for energy is finally getting to that vision of smart grid that I think the industry's been talking about for a long time, but I think we're finally there. We had a combination of algorithms, cloud architecture, and assets that you can distribute really anywhere. And I think the most compelling example of that is virtual power plants, where you can get a retail offer from an aggregator, where I give you a battery, I give you solar with zero upfront cost, and you pay a fixed tariff per month that's lower than any other tariff you can get in the market. And by having that, you then have your own distributed asset that you can island if there's a blackout, so you have resiliency at the home. But the reason why that offer is even possible now is because aggregators can take those assets and bid into markets in strategic times. And so passing the value down from wholesale markets all the way down to customers. And there's really cool examples of projects, the South Australia VPP that Tesla operates. Google it, we have a bunch of articles on it. It's probably the most advanced in the world, at least at this point, for virtual power plants. And there's more and more offers that are popping up, not just from Tesla, across the US and Europe. And I think that's really going to change the landscape of energy and make it much more resilient.
Thank you. So a question about stressors and planning. So how did each of your organizations, were you planning for something like a pandemic? How did you address that sort of in your own organizations? Because obviously we have two very large companies, two much smaller companies with us today. So from each of your perspectives, and let's start, I think, you know what, Dan, we'll go back to Eaton and talk about big, and then we'll have Travis talk about small. How about that?
Yeah, sure. Thank you. As I kind of read through the abstract again earlier, it made me think about the shift in electrical needs and really where the power is going to. Like before it was over there, in the factories and the offices and so forth, and now it's here. And a lot of the stuff has been in homes. And I mentioned it, the thing is that the grid demand is actually down, but now we have to make sure that, we're having power available where it's needed. And some of these temporary hospitals that were set up in gymnasiums and parking lots were really the requirement. So our company looked at, how do we help to make sure that the electrical resources are adequate for those facilities, especially for the ones that were temporary in nature. Our engineering services group specifically has been called on to help, quickly adjust those sources and, connectivity to make sure we can do this. And we've done that a lot of times in the past with recovery from natural disasters like hurricanes and floods like Katrina and Superstorm Sandy and stuff like that. But from a resiliency standpoint, it all comes down to, I would say like the four things, like the ability to prepare, the ability to adapt to what's going on, the capability to withstand what's going on, and the speed at which you can recover following the event. So we've worked hard to try to make sure that works. So during the pandemic, we focused our operations to keep our critical customers like utilities, hospitals, data centers, grocery stores going so that they could continue to deliver those essential services.
All right, and how about Travis?
Sure, thanks, Anna. So I'd say, as a company, we've been producing technologies to help the resilience of our DoD partners in a variety of ways by producing human-like robotic technology to support explosive ordnance disposal technicians ever since 2001. And robotics have long been demonstrated to be incredibly useful in times of crisis, given their ability to project that human-like capability while performing in a highly unstructured environment. Some recent examples that I could point to where, RE Squared, albeit maybe a smaller company as compared to Eaton or Tesla, where we've been able to make some big impacts, have been in response to remediation activities at the Fukushima nuclear incident, as well as assisting in cleanup activities for Hurricane Michael. In both of these cases, it all came down to our ability to quickly deploy robotic systems, given their flexibility and ability to adapt to those unstructured environments. So we haven't necessarily been planning for a scenario just like this, but we've been preparing flexible technology that's ready to make an impact.
Thank you. So we have a question that's come in. We have a few questions that are coming in. Thank you all. I'm going to insert one of those that's come in from one of our esteemed faculty, Jay Apt. Hope he is okay with me naming his name today. But he was curious, Julian at Tesla, what fraction of solar home customers have islanding capabilities at this point? So he says that he's aware of some that have inverters, but that don't allow in-home use of PV and battery when the grid goes down.
Yeah, that's an interesting question. So for the most part, most homes without a Powerwall do not have islanding capability. I think that's a general point. I mean, there are smart inverters that may allow for islanding, but that's like the vast majority of customers. If you have solar, that does not mean that you're protected against the blackout. And so really having a Powerwall, that's one of the main advantages of having a Powerwall or a residential battery generally. In addition to doing time-based control or other ways to economically optimize energy use. It's really, I think the biggest selling point early on for Powerwall was backup power to allow that islanding capability.
Great. We got a lot of questions coming in. I'm gonna insert another one. So we have a question, and I'm gonna throw it out to any of you. So do utility companies rely on robotic systems for their operations? So what kind of reliability should these systems have?
So I guess I can jump in here, Anna. And this actually goes back to our first webinar with Josh. We described some of the current robotic systems that have been deployed within the utility space. Currently, it's been predominantly drone-based. So a variety of different utilities are using drones or robotic systems for basic inspection tasks, but we haven't necessarily seen a lot of robotic systems being deployed that are performing more intervention-based tasks, so physically interacting with components to perform some meaningful work.
Okay. Another question. So how have your organizations been planning for losses as it pertains to resilience planning? So it could be losses of workforce, it could be losses of institutional knowledge, but how are you all thinking about that? And I'm going to merge that with a question that's come in that's talking about the possibility of adapting a variation of donut economic business models. Throwing it out to the crowd.
I'll speak to what we're doing for institutional knowledge, because we've spent a lot of time with training. Basically there's so many people retiring or near retirement age that we've decided to focus on what we're calling, training the next generation. And it's especially true as it relates to resilience planning, because I mean, when you think about like these new technologies and things that not only do those people that are retiring only have that information, but some of that they don't even have. So we have to figure out how to train the next generation. You don't see the mentorship that I had, a lot of us had when we entered the industry. I had people that were some of the best in the industry all the way back to the Westinghouse group. So it's amazing like what was there, but you don't have the opportunity to go out and actually sit next to somebody that has all that. And so I would start with the fact that most of us are visual learners. So we're trying to focus again on things that people can learn firsthand by seeing them, we say hands on, but really what we mean is eyes on for electrical things, and solar, microgrids, electrical systems. So we set up a program called Power Up, which is for new people entering the industry, engineers, electricians. Engineers see things, if they looked at what's behind me there, it's actually a transformer. They might not know what that is, but if you drew the squiggly lines on a piece of paper, they would say that's a transformer. So we need to teach engineers what stuff looks like coming out of training. And then for the other side of it is electricians. They know exactly what everything looks like. But the interesting thing that they told me many, many times in their apprenticeship program is, right when the power is getting ready to be turned on, they stop, pick up their tools, and go to the next job. So the problem is they don't know how it works if it was working correctly or incorrectly. So we're really focused on making sure they know how it works. And then we've done a lot with, especially related to filming some of the demonstrations and things that we've done here, a lot with video content for training. And then finally, I would say we've partnered a lot with universities and the apprenticeship programs to really help them to step up with some physical demonstrations and stuff for that visual learning piece.
Thanks, Dan. Any others want to respond to that one?
Yeah, and I'll build on a lot of Dan's comments there. You know, personally, I think the demographic data is pretty clear that there's a heavy bias towards particularly baby boomers within the electric power industry. So as they transition out of the workforce, so too will their knowledge. And I see two potential areas where implementation of robotics can help to kind of minimize those effects of losing that institutional knowledge as they transition out. First of which I'd say, if we're able to digitally record those work practices, either through the use of sensors or some sort of human-machine interfaces, we can probably characterize a number of those aspects of work that might not be captured as part of like standard operating procedures. Second, I think new technologies like robotics help to attract a younger and more diverse field of talent. Particularly with robotics, they hold the promise of eliminating many of the hazards that workers would otherwise have to expose themselves to. So by removing those hazards, I think you'll naturally open up a wider labor pool. And in addition, I would say the addition of actually having that new technology adds a type of cool factor, which is likely to also attract younger talent. We're already seeing this, you know, drawing back toward the comments around drone technology, we're already seeing this with the emergence of drone pilots. I mean, that was a job that didn't really exist 20 years ago. So I think by implementing, you know, robotics, we'll see a widening of the labor pool.
So a comment has come on specific to COVID-19. Maybe let's focus some of our next couple of questions on sort of specific strategies that you've implemented immediately with COVID-19. So Matineh, do you have any specific examples of things that you all have done in relationship to the impacts or the recovery efforts with COVID-19?
Yeah, so our business being a little bit different than the rest of the guests here, we are purely software company. So there are advantages to that in this kind of situation, and the fact that we can all work remotely on our laptops and pretty much business can go as usual. Was one of the benefits, right? Like, and we did, in fact, decided to stop coming to offices and work from home way before the actual state-wise lockdowns. But in terms of the impacts on what we do, which is modeling basically the behavior of the electricity grid, we do see a lot of issues and challenges there. So part of our infrastructure and software is that we have these models that forecast the behavior and the prices and the load of the electricity grid, looking at historical behavior and making decisions for batteries to operate accordingly. Now, the question is, the things that we are seeing now are quite different than what we have seen before. So the algorithms need to be adjusted accordingly to be even smarter to be able to account for those kind of unexpected behaviors. So I would say, like, for businesses like ours that are purely software, the challenge has become even bigger in terms of finding innovative ways of implementing artificial intelligence that are even like borrowing some technologies from different fields like computer vision or robotics or other fields, and coming up with algorithms that can account for these kind of unexpected behaviors, similar to a robot that is like walking around the room and saying, oh, I hit the wall, so I have to make a decision properly. This is pretty much similar. Like, we are forecasting some behaviors, oh, we hit something unexpected, so what we do. So in terms of like that, like from software perspective, we have to be a little bit more innovative and the software that we have been building for batteries.
Okay. So any other sort of specific question or specific responses that you all have undertaken in terms of COVID-19? Touched on a few already.
Just trying to actually keep everybody productive and in the company and focus. And so we miss a lot of those like collaboration, close collaboration, like benefits, sitting beside someone, looking at going to the whiteboard and collaborating. So we're missing a lot of that. So as a manager, at least I would say, like, it has been like quite interesting to work in this remote virtual environment that you have to make sure everyone is like as focused, as productive, and as excited about everything. So yeah, there has been a couple of innovative ways to move around this new norm, but because our business is software related, I cannot like point at specific guidelines, safety guideline that we have followed other than, hey, stay home and don't use public places for WattLearn business or for WattLearn related meetings and those kind of.
Okay. Any others on that particular question? Otherwise, I have more questions. They're coming in quick. So I want to make sure we get a few more in. So our last question is going to be about the path forward and sort of what we should be thinking about in terms of energy systems planning. So as you're thinking about that one, I have a couple of questions that come in. One of them is, can you talk a little bit about different negative technical consequences of demand reduction during the pandemic? So negative. Anyone?
Oh yeah, there's plenty of them. So as I mentioned before briefly, negative like reduction in demand. First of all, this demand is not going to, hopefully, is not going to stay low forever. So the question is when it's going to peak and how it's going to peak. And the other thing is the nature of the demand reduction. Right now, what has been reduced is the commercial and industrial load that is mostly have been reduced and shifted to residential load. But how that is going to change. So a lot of those uncertainties is coming. One of the very immediate impacts that we have seen, as I mentioned, is the negative prices. And that you can imagine if you are a generator and supplier, that can only be sustainable for you for so long. So at some point, if these kind of like negative prices continue, they may even force some power plants to go retire sooner than we expect. There has also been shifts in the location of the loads. For example, some companies are already talking about changing the headquarters. So as our infrastructure prepared for that shift in the load centers. Those are things that come to my mind that are very immediate impacts of this change in the load.
I have some thoughts on the power quality aspects of regaining power after an event like this. Because when a factory starts up, a lot of times there's this sort of progression during the initial startup and commissioning stages that's not going to happen when all of a sudden we have this return to work. So one of the things that we've done in some of our facilities, even office buildings, is started to prepare for that. Because when you think about, even turning the water back on or the power back on or all these things from a power quality standpoint, I think of the inrush problems with things like we saw at the Super Bowl years ago when the power went out and turned off all the air conditioners, turned them all back on at the same time and took the breakers. So those kind of things can happen when you don't really have a scenario that you've ever done in the past to kind of preface that. So that's what comes to mind with me when you go back into kind of going back into normal.
Travis or Julian?
Yeah, I mean, I think just to kind of echo Matineh's point, I think we're seeing fundamental shifts in the way people are consuming energy. Like, for example, in ISO New England, which is a market that I track closely for some projects I manage, we've seen system load be the lowest in 10 years in March and April. And so there are all sorts of planning that goes into addressing peaks. It's not just about that locational marginal price that might bounce around, but I mean, there are programs that are set up to address peaks, to reduce load. And so if load patterns continue like this, you might have stranded assets, or you might have deployed a bunch of resources to address a problem that no longer exists, right? So I think it's a fundamental rethinking about how we deploy resources to address problems. And it goes back to flexibility and being able to have resources that can do multiple things, not just one thing.
So then I know we're about to hit time, so I want to head to our sort of last question, which is really thinking about the future of energy systems. What are some of the things that we should really be considering as we're planning and thinking about it? I'm adding in a question about, do we see significant shifts in feedstock? Are we going to see more renewables, more, are we moving away, or is this a transition opportunity? Quite a few different questions have come in related to that. So what do you all think are some of the key things that we should be thinking about as we move into whatever the next transition is going to be around recovery? Let me point so I can make it easy. Dan, should we start with you, and then we'll do Travis, and then Julian, and then Matineh can come last. Matineh.
I think as we move towards recovery, again, I think as businesses, we have to think from a power perspective of how we're going to get everyone on the same page. I mean, I think our training aspects, or the hardware aspects, the things that I focus on a regular basis, which is really teaching people about power systems. It's really important, I think, as we look forward to try to create an environment where resiliency becomes important, and the renewable piece is absolutely coming, and the reason it is because of the cost benefit of what we can do today with energy storage. So 8 years ago, 10 years ago, when I put solar in here, actually it's probably more like 12 years ago, no one was putting in energy storage. But Julian mentioned earlier with the Powerwall, if you have that and you have solar, now you can do a lot more. If you had solar before, like we had, you had limitations on what you could do. So renewables are absolutely going to play a part in that. And I think, the education piece and trying to bring it all together is super important.
Okay. Travis, final words?
Yeah, I think really building on some of the comments from Julian earlier, in response to current events, I think flexibility and speed of technology are key, right? So should we encounter the next pandemic, improving our ability to adapt to those dynamic changing conditions will be key. So energy storage, artificial intelligence, connected devices, robotics, they're all technologies that can certainly improve our ability to respond to those sort of dynamic situations. But I would raise, however, that in order for those technologies to be effectively integrated, I think a lot of thought needs to be put into place regarding standards, for not only in terms of how those various technologies or devices interact with one another, but also how we maintain a high degree of safety and cybersecurity moving forward as well.
Okay. Julian?
Yeah. So, echoing similar points, the three words I started with were, flexibility, automation, and scalability. And I think that really defines what we need in the future electricity grid. And so we can't really afford to build one-off, one-purpose, manually operated stationary projects anymore. We need to have something that's more flexible. And I think batteries and renewables play a big role, because you can build those projects very quickly. They can do multiple things. For example, the largest battery in the world right now in South Australia, Tesla built that in less than 100 days. Similar stories with renewable energy projects. So you can move these projects quickly, you can build them, and they're more and more reliable because of that flexibility that batteries bring.
Thank you, Julian. And Matineh.
Yeah, quite in agreement with everybody, echoing their points of view. If I was going to pick one energy system here, I would go with batteries. But in general, if I want to be broader, I would say automation and integration are very key, as everybody else mentioned. And automation in an electricity grid is not like automating a manufacturing line. It is a multidisciplinary, very complicated. There are very few rule-based things there. So I think in order for everything to work flawlessly and under all sorts of scenarios, we need to answer a very big multidisciplinary question that requires a lot of data, a lot of help from artificial intelligence, and that also makes me think why microgrids, VPPs, and more flexible and smaller solutions, decentralized solutions are better, because the integration for them is more manageable and also less risky to that scale than a big centralized solution. So I would just pretty much echo everybody else's point there.
Thank you to all of our panelists. Thank you for all of our attendees today for participating. We certainly want to thank Eaton, RE², Tesla, and WattLearn for having you all come forward today to speak about these important topics. A reminder that we will have a survey after this session that will come to you via email, and want to make sure that you are looking forward to future events that we have online. Looking forward to seeing all of you again in person one day, and until then, hoping that these webinars can help us stay a little bit more connected. Thank you again to our panelists, and everybody have a great day.
Thank you.
Thank you.
You too. Thanks a lot.
Bye-bye.
Take care.